G'day, it's Clive Rocksinger here. I have recently got a lot of parts off the internet with regards to this circuit. Can you see that? And the purpose of this is for the design of voltage regulators. I just recently did a test with a solar panel and found that it had capacitance in it, and it says that you need to use a voltage regulator, but that circuit was an AC circuit, because it used an LM317, and this is DC, but there's capacitance in the little solar panel. And what I want to do is I want to run an AC, set an AC circuit up with a coil, which is this one here, which I made up. I think it's 8.13 millihenries, and this is my little solar panel. Now I couldn't get a voltage reading off that because it's got capacitance. So I want to set a little AC circuit up. To do that I need an AC input, and I haven't been able to get an AC input out of this and regulate it. So I wanted to be able to deal with the wattages that are being belted out by this transformer. And with the transformer, what it is you get the whole power of the transformer fall over the circuit. So you got to suck up all that wattage. So what I did was I bought I think this is a 50 watt. I won't turn it over. That new resistor now is a 30 ohm 50 watt. She's a killer. I got it off the internet, and I've set a circuit up here, and I've got theoretically 12 volt. I'm using my rechargeable Coles batteries, which work fantastic. They don't really produce the exact same voltage as brand new batteries. They're a little bit short. This is my unit I bought from J-Car for testing the battery strength. Usually only goes up to, I think it's about 3 bars less than the full value, but to give an idea whether the battery's charged, these are my battery chargers. These are 2 of them here. I've got them up on a shelf. You've got to set up for all this stuff. There is so much work and so much money and so much time that you've got to spend. This is my new one that I bought from J-Car. I've got one of those 9 volt batteries being charged up there at the moment. I recharged all of these. I'm getting about 11 point something volt. In this circuit now, what I'm going to do is turn this on, and it's actually going to manage the 12 volt coming out of there. Now that's a fair voltage for a little thing. And this is your high current module that I've designed, which is now going to go to second tier, and I'm going to put another 4 components on that, and it's going to go higher up. The reason I do this is because when you're working on a bench at home, you got a bad habit at one stage there. I had a circuit and I put something down, and I'm looking, there's a wide in there, and I thought, holy crap, did I turn that circuit off? And it was bloody live. And so what I thought was, I really need to have the stuff above the level of the bench. So all of the live wires here are all up here. None of them are down at bench level. It's all nice. And I'm trying to use as many nice connections as I can, and I'm gradually working my way towards, this is the first time I've ever built a coil that's worked. You have to get a razor blade or a Stanley knife and scrape the ends and scrape the enamel off the unit, and you're going to get an inductance, which actually is just a reactance of the coil, which is an AC resistance of the coil. So, but to set that circuit up, I had to manage 12 volt, and I've actually managed to do that. So if I turn my new motors on, and the mistake I made with these is with the silly way that they design the, see how they're marked in red. What you got to do is you actually got to put it on the other side, and see the red one would normally go on the left for 10 amp, and I didn't know that, and I couldn't get the current reading right, and I bought another motor, but that's alright, that's cool. Now we've got 10 volt coming out of the supply, and I must have left this on. And no, and here we go. I'll turn this on, and what I want is a 5-volt output. And there you have it. 5.0. Back that off a bit. No, the other way. It's a bit touchy. There you go. 5.01 volt. Lovely. Now that means that I can get an AC waveform out of this thing, coming out of the mains. It goes through the step down voltage regulator. I'll put it through the 6-volt terminal, which it's got here, which is about 12 volt peak to peak roughly, without all your voltage RMS paraphernalia. And of course I'm going to be